Okay, so firstly, it says to find the vector equation. So if you want to get the vector equation, and it's of OA, O is the point 0, 0, 0, and A is the point. Now, we've got to find out what A is. So A is sitting there. So this is the positive X out here. That's the positive Y, and that's the positive Z. And the side of this square thing here is 1. So you go in the X direction, you go positive 1, and then you go in the Y direction, negative 1. So you go 1, negative 1, and then you go up, plus 1. So that means you've got your 2 points OA. Now to find the vector equation, it is the point.
It's 7 o'clock.
Plus, it is lambda, or some form of parameter, times the directional vector. Now you could actually use any point as your first point, okay? Well, we're just going to use 0 because it is given us in the form of OA. So we're not going to use 0. We're going to use our point as A, because if it was 0, you'd see the first point would have been 0. But you can see the first point that they've used there is A, which is 1 minus 1 minus 1. So here's the actual formula: x1, y1, z1 plus lambda times, and then you get the directional vector, like OA. So the directional vector is head minus tail, so that's x2 minus x1, y2 minus y1, z2 minus z1, because that gives the direction that it's going in. What you're actually doing here, just so you have a really good understanding, so you've got this point, which is x1, y1, z1, and then from that point, you're going in the direction of the other point. So the other point, say the second point was x2, x2, y2, z2, then you're going in the direction of x2 minus x1, that's going in the x direction. So say that was x and that was y, and then you're going y2 minus y1 in the y direction, and then you're going up z2 minus z1. So you're kind of plotting like this rectangular thing, and that's where your line will go, in that direction. Say that was B and A. That's for your formula. So A was x1, y1, z1, and B was x2, y2, z2. So you take one point, which is x1, y1, z1, and then it's like finding the gradient vector, the direction of the next point, which is x2 minus okay, so that would be your line there. So let's just apply all that to this here, and then maybe I'll give you another one of just finding the equation. So your point will be 1 minus 1, 1, because that's 1 point, that's A. Your directional vector will be OA, so that will be 1 minus 0, minus 1 minus 0, and 1 minus 0. So it's 1 minus 1, 1, plus lambda 1 minus 1, 1. So in general, if you have like a point, say 2 minus 3, 4, you have another point, which is 4 minus 2 minus 1. Note it could also be written like this, minus 3j plus 4k. That would be 1 point, A, or you could have 2 minus 3 or 4. You could write it like that, 4i minus 2j minus k. That's in component form, or 4 minus 2 minus 1. Okay, so R will be a point. Now you could choose either point. So let's choose 2 minus 3, 4. The reason that it all works out, because it's all trapped in that lambda, that parameter. Okay, so you could also use 4 minus 2 minus 1 plus lambda times. Okay, so x2 is 4 minus 2. So you're doing 4 minus 2. And then you're doing minus 2 minus 3. Minus 2 minus 3. And then minus 1, 4. We're doing minus 1, 4. Okay, so that's going to be 2 minus 3, 4 plus lambda. 4 minus 2 is 2, minus 5, and minus 5. So this here is your directional vector. Your directional vector is what you use to see whether it's parallel, perpendicular, looking at the dot product. That there is like, it's like looking at your gradient. Okay, so back to this, the answer to that question would have been D.